So, hello everybody. My name is Michael Aberman. I'm working as Inspector. I'm the company CTO, and I've been doing OpenTelemetry for almost 2 years. So again, quite an experience around that, and also technical experience, and also how people use it or even misuse it. So I'm trying to take this experience to this talk today. And as Eran said, feel free to ask any questions. I really love the interaction, so yeah, feel free. So let's start by describing what we're going to do today. So today we're going to focus on a specific component in OpenTelemetry. We're going to focus on the OpenTelemetry Collector, which might be the most important one out of the OpenTelemetry stack. So I am going to assume that you are a bit familiar with OpenTelemetry. If you're not, feel free to write in the chat. But I'll start by describing what is the OpenTelemetry stack. So we'll understand the different components and the overall architecture. Then I'll start to discuss how the OpenTelemetry actually works. And we will actually configure it during this session. So it will be live coding, or at least with the collector is mostly live configuration of the collector. We'll also speak a bit about different deployment to support different scale. So let's get started. So OpenTelemetry, if you're not aware, is kind of a full stack solution to collect your telemetry data, analyze it, process it, send it from one place to another. So the way that it works is that you have the OpenTelemetry SDK. The OpenTelemetry SDK is implemented within your services, and it's going to collect traces, logs, and metrics, or whatever you're going to define for it to do. Then once this data is collected, you need to send it somewhere, and it's going to be sent to a collector, which is going to ingest the telemetry data, process it, and then export it somewhere. Could be some vendor, could be some storage. So we're probably going to store it somewhere, and then we're going to visualize it. So those are the four main steps that you have with OpenTelemetry. And if you take a look here, you can see a bit more of a kind of a stack view. So the first layer is your application. So I'm guessing that if you're into OpenTelemetry, you're probably interested, your application is probably somewhat distributed, microservices, serverless, whatever it's going to be. And the assumption is that within your services, you're implementing the OpenTelemetry SDK. And the OpenTelemetry SDK is going to collect the data and then produce it. And it's most likely going to produce it into an OpenTelemetry collector. This is the topic of today. So we're going to talk about how it looks like, how the receiving data looks like, what it does internally, and how it ships it to the destination that it's required. Usually would be a database. Databases like Elasticsearch, Prometheus, and then we'll have a visualization on top of this database. So that will be the overall stack that we're using. And let's try to describe what is the responsibilities of the OpenTelemetry Collector. So the OpenTelemetry Collector, at the end of the day, it's a data pipeline component, right? We have a producing side, and we have eventually some data that needs to serve this telemetry data. And in between, we have something that processes the data. When you talk about a data processing problem or a data processing architecture, you would find that you have three main things that you need to do. The first one is to receive the data, which is usually not that complex. It's something that you know how to receive, you know how to ingest, but talking about OpenTelemetry, we know how to receive a lot of data. So for instance, we know how to receive traces, logs, and metrics, and we know to receive them in different formats: OpenTelemetry, OpenTracing, OpenMetrics, OpenCensus, Jaeger, Zipkin, all of those things. And we know how to receive them in different protocols like HTTP, and like gRPC. Excuse me. Now, once you receive this data, we then need to process it. Once we're processing it, we want to take this data and we may want to enrich it, we may want to alter it, we want to group it by different variables, we may want to batch it in terms of performance, and eventually we want to export it and persist it to the database that we want. And we're going to see that we have two types of deployments. One is just having a collector gateway, and one is that you have an agent and a gateway. So let's look how it looks when we are talking about it. So the very first option, and that would be the go-to option if you are experimenting with OpenTelemetry. So usually you will have some host, I don't know, Kubernetes or some other virtualization, and you will have some container running with OpenTelemetry installed. Of course, it doesn't have to be Docker-based. That's just the common way that things are running today. But it could be any kind of a process that is running. And this OpenTelemetry SDK can report directly to an OpenTelemetry Collector. In this case, it would be a gateway. That means that you're going to have a lot of different collectors, all of them reporting to the gateway. It means that you have a lot of different OpenTelemetry SDK reporting to the same place. And that is a very simple deployment option. And if I'm thinking about architecture and deployment, starting with something simple might be the right thing to do, because we want to simplify this process of adopting OpenTelemetry. OpenTelemetry adoption could be complex from very different scenarios, so keeping it simple would make it very, very easy. So it does very, very simple. The only bad thing about it is that the application is responsible in sending the data to the OpenTelemetry Collector, and it needs to resolve the DNS name. It needs to transmit to a place where all the different SDKs are reporting to, so it may create a bit of a load on the OpenTelemetry Collector, and if there is a load on the OpenTelemetry Collector here, it could also have some bottlenecks in the OpenTelemetry SDK. This is why we have a second option of deployment. The second option of deployment is that the OpenTelemetry Collector, the OpenTelemetry SDK implemented in the container, doesn't send it directly to the gateway, but rather send it to an agent. What this is doing, it's creating a situation where if I have some bottlenecks issues in my gateway, it won't affect the application layer, it will affect the agent. Another thing it creates here, I can use the local network, so it will be much faster and also won't require any DNS resolve. That means the application has less impact. It is responsible, less prone to bottlenecks issue presented by the collector. And this is a deployment that will improve your performance, but it also will make everything more complex, right? The application starts to be more complex. You have more components that communicating with one another, and you have more configuration to do. And overall, you need more resources in order to run the application. So it allows us to achieve better performance from OpenTelemetry and from the application. It gives us another layer that we'll see in a second that allows us to change configurations for a specific application. It allows us a layer to add metadata for specific application. But it also creates more complex infrastructure, more complex deployment, more expensive deployment. So my suggestion would be to start simple, go with option number one, and once you have problems or you matured and you need this complexity, you can go to number two. So those are the two different deployments, and we'll actually go through both of them together. So I'll start with presenting you a simple application that is starts with a very, very simple deployment. So you will have an OpenTelemetry service. We'll have two services running with OpenTelemetry installed. They will produce traces and metrics, and currently they will produce it only to the collector, and the collector will just log the data that it received. So we have nothing else from our stack. As we progress, we will go through different phases. So we would go through different phases until we'll have a very full deployment of everything that we need. So let me show you the application that I created. So the application that I created has two services in it. We have an item service and we have the user service. Those applications are fairly simple, and they're written in Node.js, but it actually doesn't really matter to what we talk about today. So you can see here that the item service has an endpoint called /data, and once we receive /data, we're communicating with our user service, this one that we see right here, and we just respond with the payload that we're receiving. In case that we have a query string of fail, we would throw an exception. Very simple. Let's just see how it looks from what we do in the user service. So the user service, when it gets the API call to /user, it's communicating with some mock, and then it's just returning some data from this mock. Let me spin up everything, and we will just see that everything is working, and you will be able to see the traces that are being produced from this from those services. So let's do yarn items will spin up the item service, and yarn users will spin up the user service. And going to our kind of application, we are going to /data, and we received back our user data. Here, what we have is so what we have here is OpenTelemetry. There is a Jaeger. Jaeger is the visualization layer, an open source visualization layer for OpenTelemetry. And what we expect to see traces appear here. And to see that, let's review how everything works. So I already see that I have some exception. We will fix that in a second. But let's start with what I needed to do in order to implement OpenTelemetry. So you can see that in the user service, I have a tracer file that I have initialized. That's the same for the item service. So the item service also have the same one. We have the tracer file, and we're initializing it. And let's see what the tracer is, what it's actually doing. So the tracer is the initialization of OpenTelemetry, and I'm doing here basically two main things. The first one is everything that relates to metrics. So what I'm doing here is I'm saying that I would like to export metrics using OTLP, that's the OpenTelemetry protocol. And I have a meter provider, that's what allows me to provide metrics, and I'm providing the name of the service, so I know which service produced those metrics. And I'm defining that every 10 seconds, I'll send metrics, and I'm sending it to a collector that I've defined. We will see that in a second. Kind of the same configuration goes for traces. So I have my OpenTelemetry trace provider, starting an OpenTelemetry trace exporter, the provider, and this configuration right here. So I did have something to fix that, of course, I didn't. So let me just fix that really quick. So it would work and we will be able to see that everything is working. I'll explain in a second why I needed to make this change. Okay, so now what we want to see that actually this deployment works. So let's go back to our UI and we can see that we send an API call, and let's find traces in Jaeger. And we don't see them for some reason. We will see in a second why. I'm hoping I don't have something that doesn't work in my demo. That would be very unfortunate. But let's go through the configuration. We'll probably find out what's wrong. So when we started this tracer file, we defined two things, two ways that the SDK is going to export data. It's going to export our metrics, and it's going to export our traces. And I'm using here localhost, and that means that I am in my Docker Compose running something that is going to receive those files. So you can see here that here I have a few components. I have Jaeger, which we saw, that's the visualization layer that we'll see in a second. Prometheus that we will use, and Redis for the application. And you can see here that I am running the OpenTelemetry Collector, and the OpenTelemetry Collector is getting a configuration that is the collector gateway. So in my config, I have the collector gateway, and this is actually the configuration of my OpenTelemetry Collector. And now we can start and see the different section, the different portion that we have in our OpenTelemetry Collector. So let's review that. The first portion is all about how we are receiving my data. So at the beginning of the collector, we need to ingest the data, and I am receiving as OTLP, the OpenTelemetry protocol. It has to match whatever the SDK is doing. So as you remember, in our SDK, I'm using the OpenTelemetry metric and the OpenTelemetry protocol tracing. So that's matching what we are doing. And I have both support for HTTP and gRPC. Now, we said that we can ingest the data. We said that we can process the data, which currently I didn't define yet. And we're actually exporting the data. So when we are exporting the data, I'll overlook, for instance, for just a second, Prometheus. And you can see here that what I'm doing is I am logging my data. And I'm logging it at a debug level. So this is how I am receiving. This is how I'm going to export it. Now, all of that needs to be composed into a service. So I have service for traces, and I have service for metrics. And you can see right here that when I'm sending traces, I'm going to receive them at OTLP. I am not going to process them because the processor's array is empty. And everything that all I'm going to do is I'm just going to export it to my logging. I expected that it would be sent to Jaeger, but I didn't define it anywhere, which is just because I didn't remember correctly the flow of this stuff. But if we look at the logs that are sent from the collector gateway, we will be able to see the data that is sent. So let's verify that I'm correct. So data, and let's do A equals 1. Okay, so that works. And if I'll go here, and it may take a second. So data, something doesn't want to work. But we can see that we're actually getting those spans right here. And it may take it a bit more than a second, but we would find it eventually. And if not, we will fix that as we go. So this is the very first setup that you need to do. I think it's arrived. Wait a second. Data. Nope. I think my search isn't working because it's absolutely has to be right here. So this is the very first deployment. The very first deployment and the very first stages that we do in order to receive this the data that we're receiving. And now we want to see this data, right? We don't want to log it. We want to actually write it to Jaeger, so we will be able to visualize it. And this is where we're going to add an exporter. So we are adding Jaeger. And when we need to send data to Jaeger, we need to define an endpoint. And the endpoint would be to Jaeger at the port which it expects, which is this port. And because it's a local deployment, I'll use in secure true. So we're allowing it to be sent without HTTPS. So now I've defined another exporter. And I want to export the traces that I'm receiving from the collector to Jaeger. Just defining the collector won't do anything because I need to take it to the right service and define it in the pipeline. So if I have two pipelines, I have the traces and I have the metrics. Jaeger has nothing to do with metrics, so I can't add it there. But I can add it to the exporter from the logging to Jaeger. So if I'll kill this service, this Docker Compose, and spin it up again, so now my collector is going to get the data to the collector and then send it to Jaeger. And let's see that the services are still up. Let's spin them again. And now we really expect the data to actually work. So let's do hit, and we got a new user. Let's go back to Jaeger. Let's refresh it. And now you can see here that we have the item service. And if I hit find, I can see the traces that we expected to see. So this is the trace that we actually ran. So we made a call to /data. You can see it right here. And then it communicated with some external API. And we probably can find the URL right here. And looks like everything works. And as we said, if you remember that if we had the query string fail and we hit OK, we now get an exception, and I expect to see a trace that is actually failed. And you can see here that I have a trace which is failed, and we can see the data about the error with the call stack and everything. So what we did here is we actually we did something of that sort, right? We now created an OpenTelemetry container that is sending to collector, and which sends to Jaeger all-in-one. However, we still didn't define our Prometheus, right? Because we want to produce not only traces, but we want to produce metrics as well. To show you the application, how the application creates those metrics, so what we have here is we are getting the meter. That's the object in OpenTelemetry that allows us to create metrics. And we are creating a counter. And this counter is now created an instance of a counter called HTTP calls. And every time we get an HTTP call, what's happening is that we are adding the counter by 1. And that allows us, of course, to create different metrics. And of course, you can do here all kind of breakdown per the status code and how long the operation took and whatever kind of metrics that you want to have. So currently, what we are doing with it, we are just receiving it to the collector. So the collector would actually print the metric right here. So you can see in the metric, that's the log, of course. We still didn't attach it to some Prometheus, but you can see here that we are getting the metric, and it actually increased it by 1 in this scenario. Okay, so just to go through that with a bit more details on what we saw. So as we said, the first layer is the receiver, which is very simply defining how we're receiving the data. This is usually a layer that you don't need to configure much. It's just however the application is sending the data, this is how you need to receive it. And then the second layer is the processing layer. The processing layer gives the collector much more capabilities, and the capabilities are being added more and more and more as we go. So think of that you have this stream of data that you are getting, and you want to make different changes to this data stream. Probably one of the most used processor would be the batch processor, simply because when we receive data, we don't want for every receive of any data span metric that we're getting to write to the database. We want to work in batches. We want to be more effective. So we can define a batch processor. Looking at a batch processor is fairly simple. Let's add a batch processor so you could see how it looks like. So moving back to our code, if I'll look at the definition we can have right here. So we have the receiver, we have the exporter, we have the services. So I would like to have an additional section, processors. And here, what I can do, I can just add batch. And in the batch, I can add timeout of 1 second. Now what I'm doing is I am going to add it to my pipeline. And you can see it right here. So what's happening here is I am receiving data, and before I am sending it down the export path, it's going to be batch for 1 second. So it will be, so that's probably the most used batch processor out there, but it's very hard for us to see it visually. So let's add another processor that will be easier for us to understand. So there is a processor called resource, which allows us to change the data. So I can add attributes to my to the spans that I'm going to ingest. And here, what we'll have a key. Let's call it test, and then the autocomplete here is working too hard. So, and then I'll have a value, which could be 1. And the last thing that I'll do is the action, which will be insert, because I can remove, I can update, I can do all of these things. So what I did here is I created a resource process that is going to insert data to spans that we got. So let's add it to our processors, and let's rerun this Docker compose. The way that we will be able to test that is once we will observe traces in Jaeger, we would expect to see a key called test with the value 1. So let's create a new trace, and we need to wait 1 second in order for it to appear. And now we have a fresh trace that we can look for. And a question for you that you don't have to say out loud, but you can just think about: are we going to see this attribute in all the spans, or only the first one, or something of that sort? So let's test that. So let's first see that we have the trace, the test. And yeah, of course, we're not going to see that test 1. Okay, so it found it, but I can't, I didn't look in the right place. So it's right here, so we can see it in the test, and we can see it 4 times. It will just add for any spans that we're receiving. So this is allowing us to change the data, group the data, batch the data, and do all of those things. So now we got the data, we change it, and we can move on to the last part, and the last part will be to export this data. Exporting this data, you have a lot of options where to export to vendors, to open source like Jaeger, to databases like Elastic, MySQL, to tools and tools that are going to save this data, and then someone else can group that and can receive that. So if you're using, for instance, Kinesis, you can stream the data to Kinesis, and then from there you can actually go ahead and pull it and do whatever you want to do with that. Okay, so what we did here is we took the data from the collector to Jaeger, but we want to make it a bit more advanced, right? We want to take our application and now have two services, right? We want to have the collector agent and also the collector gateway. So let me jump from to the next phase, and I won't do this live coding of the change all the time. So I'll jump to phase number 2. Of course, I need to clean the changes that I made and check out phase 2. When we move to phase 2, so excuse me, phase 3. So when we move to phase 3, you can now see in our Docker Compose that we have not only the collector gateway, but also the collector agent. So you can see that the collector gateway and the collector agent, so we have both. And let's look at the configuration of them and try to understand what each of them is doing. So the collector agent is receiving data in OTLP. It's logging for the purposes of this demo, but when it's going to export it, it's not going to do anything fancy. It's just going to export it to the gateway. As we saw here, we'll have many collector agents and collector gateways. So the application communicates with the gateway the application communicates with the agent, and the agent communicating with the gateway. And that means that no change was required in the application. We just add another container that is communicating with the gateway, and the gateway right here is doing basically the same. It's receiving the data the same way, and exporting it the same way. So we just added an additional layer that allows us to kind of control the traffic in a better way. And then the next thing that we want to do is probably persist the data to somewhere, because currently when we are using Jaeger is storing all the data in memory. And we, of course, for production purposes, that's not going to work. For the demo, it's going to work perfectly. So let me jump directly to number 4. And adding Elastic is going to be very simple. So looking at our Docker Compose, of course, I need to first reset, check it out. And now what you can see is that Jaeger is ingesting the data, and it's going to have a storage type, which is going to be Elastic. And I just spun up here Elastic. And now once the data is received in Jaeger, it's going to be actually stored in Elastic. And this is going to allow us to persist the data and have scalable ability to query and analyze the data as much as we want. So we took the application directly from OpenTelemetry to the collector, and now we have OpenTelemetry, gateway, collector, Jaeger to a database. And the last thing that I didn't show you is how actually Prometheus is working. So the way that it's working is that the SDK is sending the data to the gateway, which sends it to the SDK sends it to the agent, which sends it to the gateway. And the gateway is actually exposing an endpoint that is allowing Prometheus to scrape the data. So let's spin everything up and see that it's actually working. Docker compose up, and everything is going to be spun up. It's going to probably take it a few seconds because we're exposing a lot of things. And as you can see, in our Docker compose, we are also exposing Prometheus. And Prometheus is getting the Prometheus config file. And the Prometheus config file is going to scrape every few seconds our collector gateway. So just to see this flow, the OpenTelemetry SDK talking to the agent that is sending metrics to the gateway that is storing them until Prometheus is going to scrape that. So in some cases, we have a push mechanism, and in some cases, we have a pull mechanism of those metrics. And as we saw in the application layer, every time we get an API call, we increase it by 1. So let's run an API call. Now, it may take a second to actually see that because the scrape mechanism is working every few seconds. But you can see here that the HTTP calls metric is now equal to 1. And if we have a bunch of more API calls, and we would wait a second. No, I wanted to do fail equals 1. And we would execute, you can see that we jump from 1 to 5. So this is how you can stream the different data types, different data sources. Again, I would say that, I don't know if to say most of our organization, but mid-sized organization in terms of traffic usually don't require to have the agent installed. They can usually work directly with the gateway, but this is a very simple addition that takes you far in terms of scalability and performance. One thing to add, OpenTelemetry Collector is helping you to debug and understand the OpenTelemetry performance, the OpenTelemetry Collector performance. So if you think about it, you have a very significant component that you need to know whether it's running or not. So you have a health check for that. And if you want to understand the performance, maybe you need to scale it up. Maybe you need to have more instances or more CPU or more memory. So you can use the pprof module to have performance data. And you have the Z pages for some debugging, and you have a link right here if you are interested.
Michael, one question probably about that. How many agents can a single gateway can support? Meaning, like how many SDKs, single gateway can support?
So it's not about how many SDKs. It eventually boils down to how much traffic that you are sending. Mm-hmm. So there is a table in the OpenTelemetry collector showing the kind of estimation of what you can do. And it also varies between different processor and exporter that you use. Like a rule of thumb, you could say that I would say that a single collector with not that much CPU memory can probably work with thousands of events per second. It's pretty well-built data pipeline component. But usually you just run it and understand, and then I can find later the table and share it with you.
Got it. And another question about like the service discovery capabilities of the receiver, if it has any.
So I think that eventually it's a component that you're the owner of, right? So you're exposing this component to the outside world. So it's a bit up to you. and it really depends in different configuration how it would look like. But at the end of the day, it's a program, a Docker container that you own and you expose. So probably you would need to manage that. There isn't like a thing that OpenTelemetry suggests.
Okay, cool.
Okay, so let's wrap it up a bit. So now we understand the OpenTelemetry stack, and we know actually how to configure it, and we even have an example that we can use. So it's very easy to start small and build more advanced as you go. And I think that's the approach that you should do. You should take something simple and work it up until you have something that is production ready. I think that the last deployment that I show you is, in some sense, almost production ready. And few tips before moving to production, I would say you have three things that you need to test. The first one refers to the question that I answered previously: is how much resources do I need in order to maintain the traffic in production? So put it under some load, test it a bit so I have some feeling for it. And the second thing is try to make sure that you have auto scaling in place, that the Elasticsearch or whatever database that is going to ingest the data is big enough and have some data retention on top of it. A big portion of OpenTelemetry is actually how to have the right sampling. Most large organizations choose not to sample all the data, but actually to find to sample the data, part of the data, a percentage of the data. And this is something the collector could very much help with. So this is a decision you probably need to take. And I would suggest to understand how the extension, the debugging and performance works. So if you have some issue in production, you'll have the tools to figure out and understand. Just before we move to the question part, so two important things. We do have an OpenTelemetry bootcamp. It's a free vendor-neutral 6-hour bootcamp divided into 6 sessions where we start from small and work our way up to really understanding OpenTelemetry. And it has anything that you need to do in order to install OpenTelemetry and then manage it in production in a secure, scalable way. So go check it out. Again, vendor free. YouTube doesn't require anything. And the last thing is, after the question section, if you're interested to learn about Inspecto and learn about what we do, you're more than welcome to stay. So let's jump to the questions. I would love to answer any question you might have.
What are the sampling options that probably the collector gives you, and how you should go about it?
Yeah, so I'll say that it's kind of a hard question to answer how to go about it. So I'll say, in general, you have 2 options. The first one is in the SDK to determine how much traces you want to sample. So you can decide that you want to sample, I don't know, 5%, 10% out of your data. It's somewhat limited what you can do in the SDK, as it doesn't see the whole trace. It only sees the beginning or out of the trace. And the other option that you have is to define it within the collector. The collector, of course, has a bit more power and a bit more capabilities, as it can aggregate and see all the different data, all the spend data or the entire trace, and then take a decision. So those are the 2 options that you generally have. It's called head sampling in the SDK and tail sampling in the collector. How to go about it? That's a complex question. I think it boils down to what you're trying to achieve with your tracing data. If you want to have the ability to debug any transaction, that means that you need to have 100%. If you want to find only errors in your application, then you can't just take you can't just take a percentage. You need to do something a bit more advanced. Maybe I'll touch it when I speak about Inspecto's offering. So it boils down to what we're trying to achieve with tracing data. So I see another question. What's the most efficient protocol to send data to the collector for multiple applications? That's a good question. It's a good question. We wrote a blog about it. It's actually quite interesting. It's in different languages, you would find different efficiencies. But the rule of thumb is that gRPC is the most efficient. In some languages, it may be different. In Node.js, we ran some comparison and we saw some interesting results. But the rule of thumb, I would say gRPC. In most languages, gRPC is supported. There are some languages it's not supported. The only one that I encountered which is not supported was Ruby. Okay, so I think that there is any more questions. I'll jump to talk a bit about the Inspecto. Okay, cool. So I see there is a question. Is there any documentation on any governance to follow in order to ensure how an SDK is configured with valuable metric and traces? I'm not sure that I get the questions. So I think that if you're talking about traces, usually traces are collected automatically. So they're auto-instrumented. So traces, you usually don't need to make any code changes. And you just install the relevant instrumentation and all the data is collected automatically for you. And then you are going to collect everything. And that's, then you get everything that you need. And in terms of metrics, as you saw, it's something that you need to code, you need to add to OpenTelemetry manually, and then it's up to you to decide what's important and what's not important or valuable for you. I hope I got the question right.
Yes, thank you.
Cool. Okay, so a bit about Inspecto. Inspecto is a startup company that is absolutely native to OpenTelemetry. Everything that we do starts with OpenTelemetry and ends with OpenTelemetry. We're very active in the OpenTelemetry community and the open source. And what we do is actually started with people trying to adopt OpenTelemetry and having problem with it. So we're usually really good in doing three things. We are really good in saving you the very first step with OpenTelemetry by providing you with a pre-configured installation, both in the SDKs and the OpenTelemetry Collector. So for instance, if you know Kubernetes and Helm chart, we have an Helm chart that is helping you to deploy the application, the OpenTelemetry Collector in a very easy way. And the second thing is that we know that people are having problems when it comes to working with Jaeger. So as you saw, with Jaeger, your ability to find what you're looking for is very, very limited. You always see traces for a specific service. Sometimes you don't know which service you're looking for. And if you need to search for, I don't know, service that communicate with a specific queue, you don't have the ability to do that very well. So what we did in Inspecto is we started off with making it much more clear and searchable. So you can search for anything that you want within a trace. So if you have the user ID, you can just go ahead and search for the user ID to make everything easier. And we have a predefined filter that you can, of course, change if you need, that allows you to find exactly what you're looking for. So if I know that I currently have some incident in my purchase order, I can click the purchase order. I'm interested in the post one. And now I want to find the slowest one. And I can just go ahead directly and jump to the one that I find the most interesting, let's say this one. And once I'm clicking a trace, we try to make the trace much more readable, user-friendly. It's very hard to navigate in Jaeger in a large trace and to understand the overall map. So here we created a map trying to describe the trace, so it's easy to understand that everything starts from a URL, from a browser, communicate with the other service, that communicate with the user service, and then some external API. And on any component that you click, you get all the relevant data. So in HTTP, you get the request and response data. If you're clicking in database, you can see the database query and response. And of course, you have to have the timeline in order to understand performance issues. So if I want to understand why this trace was slow, it's pretty obvious that this query made it slow and I need to fix it. So one of the things that are quite problematic in terms of visibility in messaging system in general is when you start to do async communication. You start to do async communication, the service that produced the message doesn't know whether the message was consumed, if it was consumed successfully or not. So what we are doing here, we're actually able to correlate. You can see here that we produced a Kafka message. You can see here that we can consume the message. So I can see that the message was consumed once, and I can see the trace that consumed it, and I can actually merge those two things together. And now I have the whole trace merged together. So I can see from the front end until it was persisted to the database through Kafka, all in a single view, which is something that you can't do with other vendors and Jaeger. So trying to make traces as easy and readable and simple as possible. And the last thing that I would like to show you is actually a sampling rules. So somebody asked about sampling and how to go about it. So the problem with sampling, and that this is very critical for someone who has a lot of data, is OpenTelemetry would say, okay, you need to decide how much data you want to collect. So you would say, I want to collect 5%, 10% out of my data. This will result in the fact that you would collect the 5, 10 most common traces, but it won't be the 5, 10% that interests the most. The one that will interest the most will probably be something like, I want traces that the duration is more than 3 seconds, for instance, or ones that had errors in them. So what we are doing is we're doing two important things. The first one is we allow you to have more advanced policies that you can decide how much to sample, whether you want 0% or you want 100% or anything in between. So you can change those policies depending on your needs. But what's probably even more important is that we don't require you to make those changes manually in the configuration file. You can do it remotely. So you can go to Inspecto remotely and change it as you learn your system. One of the most use cases that we see is you have an incident in production in a specific route that is having like 5% sample rate. Now, it's very hard for me to gain visibility into the incident due to the fact that it's not sampled very much. So I'll go here, I'll change the sampling rule for that particular API call, and I'll change it to 100%, and now I get all the different reasons for this incident and all the different traces. And once this incident is complete, I can go back and put it into Fire, and I don't need to make any deployments. So I think those are the three things that people find that the Inspecto provides a new layer that helps them to work with OpenTelemetry and then telemetry in observability as general. And the last thing that you can do, if you have any questions and you want to stay in touch, you can shoot us an email. But we also have in the CNCF Slack, we have a channel called OpenTelemetry Bootcamp, where all of Inspecto's team members are there, and you can go ahead, ask any questions. So thank you very much for attending, and best of luck with OpenTelemetry Collector.